What if the home you live in could be your best defense when the unexpected happens? Well, today, we're going to dig into the secrets of building for resilience to create not just a house, but a real sanctuary. So, we're starting out in a region that's just breathtakingly beautiful, but also incredibly powerful, Jammu and Kashmir. It's a land of stunning landscapes, for sure, but it's also a place where nature can be really unforgiving, with things like floods and earthquakes happening pretty often. And yeah, in a place like this, when nature really decides to show its force, the way you build your home can mean everything. It's literally the line between having a safe shelter and, well, having nothing left at all.
So that brings us to the big question, right? A question that really affects families everywhere. What are the secrets to building a truly safer home? All right, let's get right to it. The answer is a method that's been proven to work time and time again all over the world. From Indonesia to Peru, it's called the confined masonry method.
So, what's the big idea here? Well, it's actually pretty simple. You build the load-bearing walls first. Then, a reinforced concrete frame gets poured around them, basically hugging the masonry. That simple switch in the order, that's the key. It forces the entire structure to act like one solid, incredibly strong unit.
And that's the absolute crucial difference. With confined masonry, walls first, then the frame is cast around them. They become a single system. Now, the way it's often done, the reinforced concrete or RC frame method, is the complete opposite. They build the frame first, and then the walls are just filled in later. A lot of the time, those walls aren't even carrying any weight. They're just partitions. You can see how that's a massive difference in how the building's going to hold up when things get shaky.
Okay, so a resilient home. It doesn't just start with the first brick you lay. Nope, it starts way before that, with where you build and what's underneath your feet. It's all about building on solid ground.
First things first, you've got to pick your spot carefully. And the rules are pretty straightforward, but man, are they important. Stay away from low-lying areas, floodplains. You want to be on higher ground where water can drain away. Try to build on the protected side of a hill or behind some trees that can act as a natural shield from the wind. And probably the most critical thing, make sure that slope you're on is stable. You do not want to be in a landslide zone.
All right, next up, you have to know what you're building on. And there's a simple way to test the soil using something called a hand penetrometer. So a weight gets dropped and you just count how many blows it takes to push a rod into the ground. That number you get is the NHUS value. Just think of it like this. If it only takes a couple of hits, your soil is soft, almost like mud. But if it takes a whole lot of hits, you've got firm, packed earth. And it's simple. The firmer the soil, the safer your foundation's going to be. Now, let's talk about the foundation itself. On the left, you see the wrong way to do it. Just dumping a bunch of loose stones into a trench. Big no-no. On the right, that's what you want to see. The stones are laid out in careful, interlocking layers, and the dirt around them is packed down tight. This creates a way stronger base for the whole house.
Okay, so we've got a solid foundation. Now we can start moving up and talking about the blueprint for strength, the actual design of the house and the materials you use.
Okay, first thing, shape matters a lot. See, during an earthquake, a complicated L-shaped building like the one on the left, it can have these weak points where the two parts of the L twist against each other and tear the building apart. The fix? It's so simple. Just break it into two separate, strong, rectangular boxes. Seriously, when it comes to safety, simplicity is strength. All right, next up, materials. You've heard it before. A chain is only as strong as its weakest link. Well, a house is only as strong as its weakest brick. On the left, you've got these weak, crumbly, uneven bricks. That's a disaster waiting to happen. On the right, you see strong, uniform, well-made bricks. That's what you need for a wall that's actually going to stand up to some real pressure.
And that same idea applies to what goes into your concrete. You see those smooth river pebbles on the left? They're too round. The cement just slips right off them. But the stuff on the right, that angular, crushed stone, it's got all these sharp edges that lock together inside the concrete. That's what creates truly strong concrete. See? These little details make all the difference.
So we've got the right spot, we've got the right materials. Now it's time for the magic ingredient, the thing that ties it all together. That strong embrace of the confining frame.
It all starts with what's called the plinth beam. This is a solid concrete beam that runs all the way around on top of your foundation walls. And its main job is to lift the whole house up at least 150 millimeters, or about 6 inches, above where floodwaters are known to reach. This one feature is your #1 defense against flooding.
It keeps the house dry, and it keeps it secure.
Okay, now check this out. This is a tiny detail that can literally save a building. It's the hook on the steel stirrups in the concrete. A simple 90-degree bend can actually straighten out and fail when an earthquake hits. But if you bend it all the way to 135 degrees, it's not going anywhere. It holds tight when it counts. It's a perfect example of how a little bit of craftsmanship makes a gigantic difference.
And this is what that confining frame looks like in action. You can see it's this continuous, interconnected grid of concrete beams and columns. Honestly, the best way to think about it is like a structural skeleton for the house. Or maybe even better, it's like a seatbelt for your walls. It just hugs them tight so they can't fall apart when things start shaking.
All right, so let's put all of these pieces together now and watch the final resilient home take shape.
So here's the completed ground floor, and now you can really spot all those key features we've been talking about. There's the plinth beam giving it that raised base. You can see the vertical tie columns locking the walls in at the corners, and see those bands of concrete around the windows and doors? They add even more strength to the whole thing.
And there it is, the finished home, a complete, resilient system. And notice that last smart design choice, a lightweight roof and a timber gable wall. Why? Because less weight up top means less force, less shaking during an earthquake. Every single element is working together here to create a much, much safer place to live.
So, from the dirt under the foundation all the way to the materials in the roof, we've seen that these aren't just, boring building codes. They're actual strategies for survival. So I guess the question I'll leave you with is, now that you know these secrets, what's the first thing you're going to look for in any building from now on?